Sorry, I ran out of my 5-minute time limit there. So anyway, a couple of last things about this problem. If I were to look at the domain of this problem, I would say that my domain is all real numbers except -3 and 3. Another way to write this, if you want to in interval notation, would be to say from -infinity to -3, union from 3 to infinity. I use parentheses here to indicate that -3 and 3 are not included. Oops, and I'd actually have to include -3 to 3 because we get values in between -3 and 3. So -infinity to 3, -3, -3 to 3, 3 to infinity. My range would be all real numbers except 2, or in interval notation I could say -infinity to 2 with an open parenthesis there, and then union 2 to infinity, and that's saying all numbers except 2. You could also say, if you wanted to, y cannot equal 2. So that would be another way to do it. Now, you're getting this horizontal asymptotes and vertical asymptotes because of the initial problem, the way the problem is set up. We saw that the -3 and 3, that these two factors in the denominator caused our vertical asymptotes. So these guys are where our vertical asymptotes are coming from, and this is at x equals -3 and x equals 3. And then the horizontal asymptote is coming from the relationship between that 2x squared and the x squared. If we ignore this -9 for a second and just look at the two biggest powers of x, the ratio of 2x squared to x squared, the x squareds cancel out and leave you with a 2. Well, that's precisely our horizontal asymptote, y equals 2. All right, if you want any other notes, feel free to take a look at 8.3 in the textbook. Otherwise, this should get you there for graphing in this section. Thank you.